Maybe okay. If it doesn't work, oh, there it's working. Okay, it's fine. It's working.
Yes, sir.
Yeah. Okay, so let's get to the question. So, in order for you guys to answer this question for Euclidean geometry, you need to know the theorems. You need to understand the theorems, ne? That's basics. So you need to
Yes, sir.
understand the theorems. So like this one, it uses the theorem that says the angle at the center twice the angle at the circumference. So this one is the basic. So I hope you understand this one. You see, the problem starts when they combine them, like they combine the theorems in one. That's when the problem starts. So for this question, please let me know if my network is fine, because yeah,
Yes, sir. We'll do so.
sharp. So for this one, you see you've got x. Where is your x? Your x is the angle at the center. So what will be the value of the x?
Yes, sir.
So this theorem says the angle at the center is twice the angle at the circumference. So you see this.
Yes, sir. That is 96.
It will be 96, ne? So this one is quite easy.
Yes, sir.
Because the angle at the center,
Yeah.
there is your center. O is twice this angle. So you should give the reasons as well, ne? So you're gonna say x is equals to times 2 of what is it? Twice the angle of the circumference. So the angle of the circumference is a, angle A. So it's twice angle A.
Yes, sir.
So it will be 48 times 2, which is 96. So the reason will be angle at the center is twice the angle of the circumference. Angle at center is 2 times angle at circumference. So this one you know it, right? This one it's easy.
Yes, sir.
Yeah. Okay. Then let's go to y. So what is the angle of y? So you see the angle of y, let me tell you. Angle y is the same as this angle. So you see you've got two of them. So you've got C2, angle C2, which is equals to angle B2. This is a triangle, Mus. It's a triangle. So the angles of a triangle, like these angles of a triangle, they add up to 180. So
Yes, sir.
and the opposite angles are equal. The opposite angles are equal.
Yes, sir.
Then
Yeah.
there is your chord. You see? So angle Y, which is C2, is the same as that angle B2. So you already know what is X. So if you know X, will you agree if I say, just because you know the value of X, I'm gonna remove this. I'll just write 96 there at X. I'm gonna remove this. So we answered that question already. So we said X is equals to 96. So if you know X and then you write 96 there, then you will be able to find B2 and C2, which is Y. C2 is equals to Y. So because B2 plus C2, they're equals to 180, and then also you have to add it to 96. So will you agree if I say, if I write one angle, like I combine the two, so the combination of this, I'll just write it as BC, for example. I'll just write it as BC. So it will be twice BC. So I'll write it as BC.
Yeah.
You know why I'm saying it's twice? Because these angles,
Yes, sir.
they are equal.
Equal.
They are equal.
Yes, sir.
So I want to get a half.
Why is 42?
Hmm?
Why? It equals to 42.
42. Why are you saying it's 42?
Sir, I was doing the formula where you just add up to 180.
Yeah. Yeah. So you can do it that way and then you divide it by 2. Let me show you. So you just say, yeah, that's the formula that I wrote. Yeah. So you're going to say 180 minus 96 is equals to 2 BC.
Yes, sir.
So this will give you 84, if I'm not mistaken. Ne?
Yes, sir.
This will
Yes,
give
sir.
84 equals to 2 BC. You understand why I'm saying it's 2, ne? You understand where I got that 2, because it's twice, like the
Yes, sir.
yeah, okay. So BC will be equals to 84 divided by 2, which is what we got.
Yes.
So it means B and C. The reason why I'm saying BC is because I'm saying B and C, they are equals to 42.
Yes, sir.
42 degrees. You need to write that degrees. Don't forget to write degrees because it will be wrong. So it's 42.
Yeah.
So we know that B2 is equals to C2. Then the reason you can say, so the first reason, remember for every step you need to write a reason, guys. So, yes.
Isn't the reason red eye that CO equals to OB red eye, therefore C2 equals to B2?
Yeah, you can use that reason. There's two reasons you can use. Yeah, there's a lot. Yeah, you see,
Yes, sir.
Mpo still remember these things. You see, you see,
Yeah.
there's your center, ne? So if you've got
Yes, sir.
one line from the center to the circumference, it's radius. And then if you've got another one, it's radii or radii, because there's two of them.
Yeah, red eye. Yes, sir.
Because there's two of them. So this side is equals to that side. So the angles of this are gonna be equal there, those angles. So you can use that reason. If you decide to say B2 is equals to C2, then the reason will be. And then what will be the reason for this one?
Interior angles of a triangle.
Thank you. They add up to 180. Yeah. Interior angles of a triangle. Angles of, you can write it like this. Interior angles, that for sure you know about it, ne? This symbol, that it means angles. And then
Yes, sir.
this means
Angles. Yeah.
This means triangle. So interior angles of a triangle.
Yes, sir.
They add up to 180, or the sum of the triangles add up to 180. You can use any definition. So yeah, you see, we are moving, ne? So
Yes, sir. Yeah.
so now, can I ask you an interesting question, guys? What will be B1 and C1? Just for interest sake.
You want to see what?
Yeah, I'm just asking for interest sake. Just in case if they, it's not part of the question, but we need to like discuss it.
Yes, sir. Yes, sir. Sir,
Mm-hmm.
I would have went with the mere fact of saying in triangle ABC, angles A, B, and C add up to 180.
Mm-hmm. Yeah.
And then from there, you're going to subtract the 180 with the 48 to receive the remainder. And then from the remainder, you can split it on both sides.
Yeah. Because you know what?
But in order to get, yes, sir.
Yes. Yeah. Continue.
Yeah, I was saying, but in order to get C1, you subtract, after dividing the two values, you subtract C2 from C1, from the original value of the whole C, in order to get C1.
Yeah. What is the original value for the whole C?
Let me just see.
Yeah. Tell me that value. That's what I'm looking for.
Yes, sir.
Mm.
132 divided by 2, which means it's going to give us 6. Yeah. Yeah, 66.
So you are saying the whole of C is 66.
Yes, sir.
Okay. So you said to get that value, you said 180 minus 48, and then you got
Yes, sir.
a value that you divided by 2 to get B and C. So
Yes, sir.
You said 180 is equals to B plus C, the whole of B plus C. Then you know that A, what is the other one? Let me see, what is the other value? It's A plus A. Okay, so
Yes, sir.
you're gonna say 180 minus 48, which is A, then you got B plus C.
Yes, sir.
So this B plus C obviously
Yes,
is gonna be twice, so we can just replace this by 2BC. You can put it that way.
Yes, sir.
Then, or you can divide it later. It's up to you. It's up to you how you wanna do it. So
Yes, sir.
let me bring my expensive calculator now. I have to use it. I have to. Is it up
Yes,
here?
sir.
You can see it, ne?
No, not yet.
Yes, sir.
Then I have to present the whole screen now. You have to see it.
Yes, sir.
You have to see it.
Yeah.
Then I have to present the whole screen. You have to see this calculator, guys. You have to. So Mpo, do you see that we can have a session for like 2 hours? Because you are saying I should record for like 10 minutes. So I wonder it's over 10 minutes now.
Yeah.
Yeah. You see, Mpo? Where's the option?
Yes, sir.
I don't have that option to record the whole screen. No, it's fine then. Okay, I have to pause this. I'm only gonna record a portion. So the area that I'm gonna record is this one.
Yes, sir.
You see the area that I've just highlighted with the recorder? Yeah, that's the area that I'm gonna record because I don't want to record the whole screen. So let me bring my expensive calculator now. Now you'll be able to see it. If you don't see it now you have to see it. Yeah, you see? Yeah.
Yes,
So you're
sir.
gonna say 180 minus 48. Then you get 132.
Yes, sir.
Then you'll have 132, which is equals to 2BC. Then your B and C will be
Yes, sir.
equals to BC will be equals to 132 divided by 2, which is equals to divided by 2. Divide.
Yes, sir.
You see now. So what did you get when you divided by 2?
Isn't it 66, sir?
Yeah, 66.
66.
Just write it
Yes, sir.
66 degrees, okay? So that will be your
Yes, sir.
B, the whole of B and the whole
Yes,
of
sir.
C.
Yeah.
So C is equals to B.
Yes, sir.
Okay, sharp. Then
Yeah.
we're gonna find what are we looking for? We're looking for angle C1, ne?
C1.
C1 is
Yes,
equals
sir.
to
And B1.
Okay, let's do this. Let's just say the whole of C is equals to angle C is equals to angle
Yes, sir.
C1 plus angle C2.
And goes C2.
Okay,
Yes, sir.
so angle C1 will be equals to so let's get C1. C1 will be equals to
We can make it X.
66 minus
Yes, sir.
what did we get?
Sir,
Mm-hmm.
how sure are we that the B and C are the same size?
We are not 100% sure.
Yeah, because they didn't tell us that CA is equal to AB.
We are not 100% sure because you see this, we are not 100% sure because this and this, they might not be equal. Although the inner part is equal,
Yeah.
they might not be equal. Because if let's say it's like this one is thinner and then this one goes further, you see the
The
difference.
other one is wider. Yeah.
You see the difference. So we are not 100%
Yes,
sure.
sir.
Yeah, we are not 100% sure that they are equal.
So we can't say that. So we can't say that C and B are equal to 66 together.
We are not 100%.
Not 66 to 132 together.
We are not 100% sure.
Together they add up
To 132.
Yes.
The combination of those, they add up to 132.
Yeah.
But to get C1 and B1, how can you get them? Because that's what
I'm not sure, sir.
Because that's what we are looking for.
Yeah.
Yeah.
And they might not be equal. So you see, to get the exact value for C1 and B1, you need to know one of them.
Yes, sir.
But you know that C1, you know that these two, BC, they add up to 132, like I'm supposed to say.
Yes, sir.
Yeah. So, because that's not a triangle, that's the problem. It's not a triangle.
Yeah.
It's a skewed triangle. Yeah. I agree with you, Mpa, because you can't be sure. But
Yeah.
the combination is that one.
This
C1 plus C2 is equals to 132. That one we are 100% sure because it's a triangle. Although it's not hey guys, let me get something to drink. I need water.
reasoning, can you mention the theorem?
Give me one example. Like
for instance, with this one, for let's say you can see that it's everything is according to theorem 1, for instance.
yeah.
Can you say in your reasoning theorem 1?
No. You need to be specific.
You can't.
You need to be specific.
Yes.
Like what? On theorem 1, what? It's like you're saying chapter 1, but you don't know what is the like you know,
Yes,
the
sir,
sub chapters. You have to say,
yes,
you have to be specific that it's okay, it's theorem 1, but what on that theorem 1? Theorem 1 is like a chapter.
Yes, sir. Yeah.
But you need to specify the sub chapters, like theorem 1. You know that it's theorem 1, but what is it on that theorem?
Yes, sir.
Like you can have two reasons on this one, like the one that I wrote now, saying line bisecting a chord, or you can say the line from the center, which is straightforward. From the center, you see center O, line from the center is perpendicular to the chord. Your chord is CD. So if the line from the center is perpendicular to the chord, the angles, they're equals to 90. F1, they didn't specify that there's F2, but the whole of F is equals to 180, and then F1 will be equals to 90, and then F2 will be equals to 90.
Yes, sir.
Yeah. Okay, so F1 is equals to 90, ne?
Yes, sir.
Yes.
So you can say line from center to midpoint of a chord. So you see it goes to the midpoint of the chord, to chord, to midpoint of the chord. Line from center to midpoint of the chord, or line from the center perpendicular to the, it's fine, any reason as long as they understand it. There's a lot of reasons, guys. Or bisect.
Yes, sir.
Obviously it cuts. If it cuts through the chord, it will give you 90. So what is angle B? They say angle B. They want angle B on that ABC.
150.
150. Okay,
Yeah.
so you see, F is the midpoint of the chord. You see, already they gave you a reason. Angle from the center to the
Yes, sir.
midpoint of the chord CD. You can specify that chord CD. You see, it's easy. Okay, and then they gave you D. Let's write D. It's an adjoint by OF. Okay, it's fine. So Mpo is saying it's 150. Why? Why are you saying it's 150? How did you get that 150?
Properties of a cyclic chord.
Hmm?
I was going to say properties of a cyclic chord.
No, when opposite
sure.
angles of a cyclic chord.
Oh,
What did
Not
that?
properties.
Opposite angles of cyclic chord. Okay.
Of a cyclic
cyclic
chord.
chord.
Yeah,
Oh, yes, sir.
but I need to know, what is a cyclic chord?
A cyclic is like a cyclic chord. It could be, for me, I define it as 4 points touching the circumference.
Yes, sir.
Yeah, I agree. It's like if you draw a quadrilateral, like if you've got a circle like this,
Yeah.
then you draw
Yes, sir.
something like this. You see, cyclic quad. What is quad? Quad is 4, ne?
Yes, sir.
Yes.
Quad means 4. So cyclic quad. Cyclic, it's a cycle. Cyclic, it's a cycle. Cyclic, it's a cycle. So there's a cycle and what?
A quad.
And a quad. You see?
I don't know quad. Yeah.
Ah. So yeah, you see, cyclic and a quad. So there's how many points in that quad? There's this gives you 4 points. That's why you're saying it's a quad. There's a cycle and a quad. Cyclic quad.
Yeah.
That's why sometimes they say quadrilateral. Quadrilateral has got 4 points as well.
Yes, sir.
So that this thing is not it forms part of quadrilaterals, but you can't say it's a quadrilateral because of the shape, its shape. You see the way it is, like the way linkating, like
Yes, sir.
Yeah.
you can't say it's a slightly quadrilateral. So, but it forms part of the quad.
Yes, sir.
So this one is inside a circle. It's not a quadrilateral. It's inside a circle with 4 points. So that's why I'm saying cyclic quad. That's your reason. So it's easy to remember
Yes,
that one. Mpo. Hey. Mpo is ready, you see?
Yeah.
Hey. Yeah. So these angles of a cyclic quad, they add up to 360, all of them, ne? In total.
Yes,
In total, they should give you 360. So guys, remember this as a cycle. Cycle is a 360.
Yes, sir.
So angles all around, they add up to 360. So if this one is 30, for example, then the opposite angle will be 150. So the opposite angles of a cyclic quad or a quadrilateral, they add up to 180. Do you guys agree?
Yes, sir.
Yes, sir.
Yeah. Then if let's say this one is 50, for example, then it means this one will be 130. And then when you combine all of them, those will give you a 360 because they are inside a cycle. They touch a cycle in 4 points. So the combination of them will give you 360.
Yes, sir.
You get it?
Yeah.
Sharp. Okay. Let's proceed. Okay. See now, guys, it's a lovely Saturday. Like, yeah, we'll have another one. After this one, we continue. 2 hours. We'll go for 2 hours. As long as there's no network problems, we continue. Okay. What's the next one? So we agree that B is 150 because this one gives you this one gives you 30, then this one should give you 150 because it's opposite to that angle. You see, they are opposite.
Yes, sir.
And then these two also give me the angles of. I know they might not ask this one, but I need to know. It will be difficult for you to know these angles A and C because you know why it's difficult. You know that D angle D plus angle C plus angle B plus angle A. That's what you know. They add up to 360. And then also, you know that angle D plus angle B, because they are opposite angles, they add up to 180. And then you know that angle A plus angle C, they add up to 180. But you can't find two unknowns. You don't know A and then you don't know C. So it will be difficult for you to find angle A and angle C, not unless you know one of the angles. Ne? Although you can combine them.
Sir,
Yes.
isn't angle C 30 degrees?
Why are you saying it's a 30 degrees?
Formation of
I might be wrong, but isn't it supplementary angles B and C, meaning that they equal to 180 degrees?
Supplementary angles. Hey, you see, I'm mentioning some things. Hey, supplementary. There's complementary and supplementary.
Yeah.
So complementary is it's 90, and then supplementary is 180.
Yes, sir.
So Mpo, are you saying angles of a straight line? Because remember, a supplementary is angles of a straight line, like your O, the whole of O. The whole of O.
Yeah. It's 180.
It's 180. Then now let's go. You are saying B and C, they are supplementary. What about A? Because they are in one line. Although they go through the points,
Yeah.
it's like it's going like this. They are going through the points. So if you are saying this and this, they are equals to 180. I need to know why. I know that if I extend this, like let's say this continues, we are talking about straight line now. If I continue doing this, do you agree that we will have B1 and B2 now? Do you agree that this is 180 now? That is 180.
Yeah.
So then that's when you can start checking the alternating angles or the exterior angles. So I know that this angle right here is 30 degrees. But will that angle help me to find anything?
No.
You see? So it will be difficult for you to find that angle. It's possible to find it. I won't say it's impossible. It's possible, but you're gonna struggle to find it.
Yeah.
Remember, there will be an alternating angle. If you do this on this one, there's an alternating angle. Right? That's your
Yes.
alternating angle. Then if it continues straight like this, you see, I didn't want to get to this part because it's a hassle. Then if you continue straight like that, you know that this angle is 150 because this one is 30 and then it's a straight line. Then it will be difficult for you to find this angle right here. Let me highlight it in blue, this one. It will be difficult to find that one. And then it will also be difficult to find the inner one, like the whole of A inside. It will be difficult for you to find them. Ne?
Yeah.
Yeah. Oh, hectic. Yeah. It's math. Math. So, hey, don't touch it. Don't even start. Don't even attempt. Yeah. That's why they didn't say find it. No, they didn't even try to say find it. They know it's gonna be difficult. So let's work with the next one, 8.3. They say in the diagram, AB and AE are tangent to the circle at B and E respectively. So guys, hopefully we're gonna finish this. Ne? Yeah, we're almost done. Let's finish this and then we know that on the next one we do another question paper. So they say these are the tangents to the circle AB. AB. Let's go and see AB. What is a tangent, by the way? What is a tangent?
A line that touches a circle at one point.
Yeah. Ooh. Ooh. Yes. Yeah, ne? Ay, 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 Kawi. Yeah. So look, let's check without you even knowing. This is your tangent, and then this is also a tangent. So even if you had a tangent also, guys, you can have a tangent in a graph. Like you'll have a graph and then over a straight line like this. That line is a tangent. That straight line is a tangent because it touches the graph at that point there, at one point. Yo, okay. No. Okay. They say in the diagram, okay, we know that it's a tangent to the circle at AB. At AB and AE. And then they say tangent to the circle at B and E. You see, at one point, at point E and point B, that's a tangent. Respectively. BC is the diameter of the circle. BC is the diameter. What is a diameter? Pella, you need to know these things. A diameter is twice the radius. Yeah, it's a straight line between a circle that passes through the center of the circle. So it's a straight line that passes through the center of the circle from one point to another. Ne? From this point to that point, it's a diameter. So you know that a diameter, the center of the diameter is 180. So this side is a radii. It's a radii. If you're saying, let's say this was D, for example, BD, it's a radius. CD, it's a radius as well. Okay. Sharp. So let's go to the actual question. They say diameter and then AC, line AC is equals to 30. AE is X. I know that they're gonna look for this thing. Then BC, they say, is equals to X plus 7.
X plus 7.
Okay, let's go to the question. Here's the question. They say give reasons for the statement below. Are we doing 8.3? Yeah, 8.3.1. They say ABC is equals to 90. That angle B. The angle B, let's go to angle B. Angle B, they are saying it's 90. Okay, I agree that it's 90. This is a right angle triangle. You see that? But
Yes, sir.
why? Why are you saying it's 90? I understand that it's 90 because it's if you have got angle like this, a right angle triangle like this, it's a 90 degrees, but you need to specify why. Why are you saying it's a 90 degrees? Why? You need to give the reason. Mm-hmm.
I might be wrong, but
Yeah.
can't you say it's the tangent perpendicular to the diameter?
Yeah. Tangent. Where's your tangent? A tangent is a straight line.
AB.
Remember this,
Yes,
guys. A tangent is equals to straight line. So it's a straight line. So you have got a tangent now. It's a straight line. And then you've got a diameter. You've got a diameter. Can a diameter be something like this? No, the diameter will always be a straight line as well. So it's more like you've got two straight lines that are bisecting each other or something that are touching each other, that are perpendicular to each other. Even if it was in the middle there, if it was in the middle from the center, you see, it's from the center. Let's say you put a point there at the center. What did you say it was the reason? Let's say it's like this. We take it from there to there. This one is a chord because why? It's a chord because it's inside the circle from one point to another. It's inside a circle, but it's not passing through the center. That's a chord. So a chord and a tangent, guys, for as long as they are being bisected by a line, a straight line, they give you 90 degrees. Am I making sense?
Yes, sir.
Yeah. So a diameter is just twice the radius, so it's a straight line from that point to this point. Ah, poor man. Hey. How? Gabi? Pasal.
Hey, sir.
There's how many minutes left? You see now this thing.
15.
15. It's fine. 15. Hey, it's a lot. It's fine. Let's finish this. Okay. So Mpo, yes, that's correct. The reason is tangent perpendicular. As long as you know how to identify these things, guys, you need to identify these things. Tangent perpendicular to diameter, or if you take it from the center, what will it be? If you take that line from the center, not all the way, it will be tangent perpendicular to radius instead of diameter. But now since they give you a diameter, you're gonna say diameter. Then what is AB? They say AB is equals to x. Let's go. AB is equals to x. So where's your tangent?
Sir,
Yeah.
isn't it tangents at the point?
Yeah, because you see, look at this. These tangents are at a common point. You see this? This is a point, and then this is also a point. So that's why I was saying, you remember that I wrote two lines, meaning they are equal. I wrote two lines, remember? So these two lines represent that AB is equals to AE. That's why I wrote the two lines there to show that AB is equals to AE because they are the same. They are yes, Mpo. Mpo. Hello. Mpo.
Asking, can you please repeat you are cutting?
Oh, sorry.
Asking, can you please repeat what you said you are cutting?
Oh, is it fine now?
Sir, can you hear me?
Yeah, I can hear you.
Sir?
Mm-hmm. I can
Yes.
hear you.
Yes, I was saying, can you please... Yes, sir, I can hear you too. I was saying, can you please repeat what you said before, because you are cutting a little bit.
Oh, I was saying, the reason why I wrote the two lines to show that they are equal. AB is equals to AE. That's why I wrote the two lines, because they are both a tangent. And then they've got a common point, you see? Point B and point E. If you've got two tangents that are at, look at this. There's a common point. What is the common point? This is where they are meeting. They've got a common point. Common meeting point. So if you've got two tangents that are going to the same point. Yes. So if you've got two tangents that are going to the same point, then it means their lines are equal. The tangents are equal. Do you get my point? Okay. So you've got 2 points that are, you've got two tangents that are going to the same point, which is a common point. So you can say, the reason there you can say line or a tangent AE and AB, they share a common point or a common meeting point. That's the reason that you can give. Mpokana, what was your reason? So you can say common point A. Can you guys hear me? Hey, I think there's a network problem.
Yes,
Yes, sir.
Oh, okay. So you can say tangent sharing common point A. Tangent AE, you can specify that AE is equals to AB because they are sharing common point A. You see, there's A. They both have A. AE has got A, and then AB has got A. You see, it's a common. It's common. Sharing common point.
Sir,
Mm-hmm.
my teacher, like yo, last year, because we didn't touch on Euclidean that much. Because in my workbook from last year, I wrote tangents at a point. Is that fine as well?
Tangent at a point. Yeah, you can say tangent
Yes.
at a common point. Just specify that a common point A. Just specify. It's correct when you say tangent at a point, but specify which point. Common point at a common point.
A.
Yeah.
Okay.
Tangent at common point A, just to be safe. Because you are specifying at a common point. What is a common point? It's like you telling someone that they are going to a common point, but what point? What is the point?
Yeah.
You see, so it's better to specify that at common point A, they are meeting at point A, so they are equal because they are going from a circumference A, they are going from a circumference B and circumference E, then to the common point, so they are equal. But you don't have to write whatever that I was saying now. I'm just telling you that they started from the circumference going to a common point, which is B, which is A, I mean to say. Okay, so let's go and calculate the length of AB. What is the length of AB? Let's go. Where is AB? AB, AB, AB. Okay, so AB, how? What are they looking for? So AB,
I think so. We have to solve for X.
Oh, you have to solve for X. I was surprised. What is AB? Okay, so AB is equals to X. So we're gonna write X. So how can we get X? Okay, so now we need to know. You see this point that they gave you? They gave you AC.
So?
Alternating angle. Do you know the alternating angle like this? It's an alternating angle, this one.
Oh yes, I was going to ask if we are not going to use Pythagoras.
Even Pythagoras can work. You know why? Because this is a 90 degrees. If that is a 90 degrees, wabana Kavi. Welcome back, Kavi. Ow. Ish. How?
Yes, sir.
Welcome
Sir?
back. Yes. Mpo.
Sir,
Mm-hmm.
can you also use the area of a triangle?
Yeah, you can use the area of a triangle. You can try to use the area of a triangle. Meaning you're gonna use that formula half. You wanna use that formula half times length. Half base times length times height, I mean. You wanna try to use
Have
base times
perpendicular
height.
to height.
Okay, let's use two methods. Let's use both methods. I know you see the one
Yes,
for
sir.
the area method is quicker than the Pythagoras. So let's start with Pythagoras. Let's start with Pythagoras. So we know that we are looking for AB. So AB, so when you do Pythagoras, what is your hypotenuse? What is your the longest side is your hypotenuse, or the side that is angle that is opposite to the 90 degrees is your hypotenuse. Ne? So you're gonna say AC AC squared is equals to guys, I don't like to do it this way with the squared. I just like to use the square root there instead of doing the squared. Just use the square root. And then you know that you're gonna say x squared plus x plus 7 all squared. Guys, can you still hear me?
Yes, sir.
Okay.
Yes, sir.
So what are you gonna get when you expand it? What are you gonna get? Okay, it's quicker, but I don't want to teach you this quick method. You're gonna get x squared plus 14x plus 7 squared, which is 49. So there's a quicker method to do these things, to expand it. But I'm not gonna teach you guys this method. It's a cheating method. So just for interest sake, I just square the first one, I square this one, and then I also square this one. So I squared that one, and then I also squared that one. Then the last thing that I'm gonna do, I take the squared, the 2, whatever I have there, I multiply everything. I multiply 7, positive 7, and also positive x. So I'll get 14x. So the answer for this one, it will be, yeah guys, I think I lost the network connection. Welcome back. I noticed that I lost the network connection. It's fine. Can you hear me now?
Yes, sir.
Yeah.
Yes, sir.
So what is the answer there? You're gonna have x. You're gonna have 2x squared plus 14x.
Presenting.
Well, I'm not presenting. Let me present. I'm presenting now. Ne? Let's finish up this question. So what will be your answer? We know AC. AC is 13. It seems like we have to say 13 squared is equals to 2x squared plus 14x plus 49. And then you're gonna take the 49 to the other side. You're gonna say 13 squared minus 49 equals to 2x squared plus 14x. Here you're gonna use a quadratic equation, I can tell you now. So what did you get? What do you get when you say 13 squared minus 49?
$120.
So you'll get 120. 120. Okay, let's take it to the other side then. Let's rearrange it. Here you're gonna have to use a quadratic equation. So you're gonna say 2x squared plus 14x minus 120 equals to 0. So you can divide. Can you guys still hear me? You can divide throughout by 2, and then you'll have 7. You'll have 7x minus 60. Then from here you can use a quadratic equation to find the factors. What are the factors here? What are the factors? What are the factors of 60? If it's not 2 times 30, then it's what? Remember, 6 times 5 is 30.
4 times 15.
4 times?
15.
So, will 4 and 15 give you 7? 15 minus 4. Will it give you 7? (15 minus 4). So you need the factors that can give you 7. You need the factors that can give you 7. So normally I prefer using a quadratic equation in this case. So I can use a quadratic equation here to find the factors. So I prefer using a quadratic equation. Let me use a quadratic equation. So if we use a quadratic equation, we're gonna get x is equals to minus b squared plus or minus the square root of b squared minus 4ac over 2a. Okay, then from here we're gonna go and get the values. So we have x squared plus 7x minus 60, which is equals to 0. So it's your a plus b plus c, right? So to solve this question, you're gonna say x is equals to, so the factors of this, if you use factorization, you're gonna have x, and then what are the factors of 60 that can give you 7? So you're gonna have 12 and 5. So 12 and 5 will give you this value, or you can use a quadratic equation. It will be straightforward. So one must be positive, one must be negative. So 12 will be positive, so that we can get 12 minus 7, we can get 7x. So x will be equals to 5, or x is equals to minus 12. So obviously we cannot get a negative length. We cannot get a negative length. So x will not be equals to, so you can write not equals to negative 12. You cannot get a negative length. And that's all for today.